Here's a look at a key for the test for the first midterm. Page 1 there. For a given atmospheric pressure, the lighter fluid will go up higher in a barometer, and that's the one with the specific gravity of 0.85. Number 2 here, the water level in both cases is at the same elevation, and the valves in both cases are at the same elevation. So that means the pressure at valve A is equal to B. There'd be no difference in the pressures because the elevations of the water level and the valves are the same. Number 3 there, the density of the water would be higher in the winter, so the tank would weigh more in the winter because it's coldest in the winter. This next one should be number 4 here. You want to know the pressure at 28 feet. So you take 28 feet times 0.433 psi per foot. And then the specific gravity is 1.24. So you multiply by that also, you get 15 psi. Number 5 there, you want to find the specific gravity. So you find the volume of the tank. 8 by 6 by 12, that's 576 cubic feet. Divide that into the weight and you'll get the density of the fluid in the tank. Then you compare that to the 62.4 for water and you get a specific gravity of 0.89. The one after that, you want to find the depth of the middle of the window, 14 feet times 0.433 psi per foot, that's 6.06 pounds per square inch. Then you want to find the area of the window in square inches, 24-inch radius, which is 2 feet, which is half of the 4. So half of 4 is 2 feet, and then 2 feet is 24 inches. So pi times 24 inches squared is 1,810 square inches. Multiply that by the pressure, and you get 10,970 pounds of force on the window. Okay, the next page here, we've got a 60-foot high water line in the building, service line. Okay, 60 feet, if you multiply it by 0.433 psi per foot, comes out to 26 psi difference. So if the pressure at the water main there is 40 psi, the pressure at this 60-foot height would be 26 psi less. So that would be 14 psi at the 60-foot height. Okay, the next one there, we've got the weight of the block at 9,400 pounds. We then submerge the block in water. You want to find the buoyancy force, so to do that, you find the volume. 3 by 4 by 6 gets you 72 cubic feet. Multiply that by the specific gravity, or the density, I guess we'd say, of water. You get 4,493 pounds. That's the buoyancy force pushing up. The weight is going down, that's 9,400 pounds, so the difference is 4,907 pounds. So that's the weight in the water. The last one there, you've got 27 inches of mercury barometer. The total for mercury barometer is 30, so 27 over 30 is 0.9. So working your way up from a total vacuum at 0, you're going 90% of the way up. That leaves 10% above. Okay, so you got 90, if you draw a line across the chart there that you'd work with, you got 90% of the line above, 10%, excuse me, 90% below, 10% above. So for PSI-A, you're starting at 0 at the bottom, working your way up, so you got 90% of the total for PSI-A. 90% of 14.7 gets you 13.23 PSI-A. For a water vacuum, your 0 is at top, and then you're going down to the line 10%. So the total for water vacuum is 34 feet. 10% of that is 3.4 feet of water vacuum. So that's a run through the test there. If you scored less than a 70 and you'd like to get your score up to a 70, I can put a quiz in the testing center, the Red Cedar Hall 111 testing center for you. That quiz will focus on density and specific gravity, on the relationship between height and pressure, and on force being pressure times area. I'll put that down in the Red Cedar Hall 111 testing center if you'd like it, and you can get your score up to a 70 with that. Just let me know about that and I can do that.